friends, welcome to my channel. I hope everyone is doing well. Today we are going to solve another popular Leetcode coding question 738 monotone increasing digits. So this is a medium complexity quite likable coding interview problem. So we are going to go through this problem, understand this problem. I created some examples for you guys so you can clearly understand the logic as well as the solution to solve this coding problem. If you are new to this channel, please subscribe to this channel now. Your subscription is really valuable and important for us. It really helps and supports this channel. Here we create videos to help others in their coding and Java interviews. So let's start. An integer has a monotone increasing digits if and only if each pair of adjacent digits x and y satisfies x is less than or equal to y relation, right? Give an integer n, return the largest number that is less than or equal to n with monotone increasing digits. Okay, so this is what we want to find out. Let's take a look at the constraint. Says that the n is between 0 to 10 raised to 9 inclusive, right? So they have given us some examples. So for 10, the monotone increasing digits which is less than equal to 10 is 9, right? Uh, less than or equal to 10 is 9 basically. Monotone increasing digits for 1 2 3 4 is 1 2 3 4 basically, right? For 332 it is 299 because this is the monotone increasing digit, right? So what monotone increasing digit means? So let's understand this better with some other examples. So monotone increasing digit is a digit like this basically, right? So for example, this one 2 3 4, right? For example, 2 3 4 is a monotone increasing digit, right? Why? Because every pair you see this 3 and 4, so 4 is more than 3, so it's uh, increasing basically, right? It should be greater than equal to 3 basically, right? Which is true. 3 is greater than 2, right? So if you take relation between 2 and 3, 3 is greater than 2, so it's a monotone increasing digit basically, right? What if I say 4 and 2, then is it a monotone increasing? No, right? Because 2 is smaller than 4, right? So it's not a monotone increasing digit. So I hope you are understanding the idea of what is monotone increasing digit, right? Um, Other thing is, let's say I have a 458 here, right? So is this a monotone increasing digit? Yes, because everything is following that rule, right? 5 and 8, so 8 is more than 5, 4 and 5, right? So 5 is more than 4, so it means that this is a monotone increasing digits, right? So now you understood what monotone increasing is, right? And what is not monotone increasing. For example, 987, if I write 987, this is not a monotone increasing, right? Because 7 is not greater than equal to 8, 8 is not greater than equal to 9, right? So this is not a monotone increasing digit, correct? Okay, so we have discussed what monotone increasing is. So how can we find out that number which is uh, largest number but smaller than or equal to this number basically, but it should be monotone increasing, right? So this current number, is it monotone increasing? This is not a monotone increasing number, right? Why? For example, because if you take a look here, this 2 and 6, this is not a monotone increasing, right? Means because 2 is smaller than 6. So this is the place. So if you start looking into this number, for example, from back side, we are going in this direction, okay, in this direction. So 6 and 5 monotone increasing, yes. 5 and 4 monotone increasing, yes. 4 and 3, yes, because 4 is greater than equal to 3. 3 and 2 is also yes, right? So we are at this index basically, okay. When you are at this index, you compare this 2 and then this 6, right? 2 and 6 you compare and you find out that it's breaking. Now it's not a monotone increasing basically, correct? Because 6 is more than 2, right? So it's not a monotone increasing at this point. Which point? Here. Here it's breaking basically at this point. So what we can do actually is, what if I reduce this 6 to 5? Let's say if I reduce this 6 to 5, right? 6 to 5, and then I will keep checking for the remaining numbers. So let's say I reduce this 6 to 5 and 5 to 5, is it monotone increasing? Yes, because 5 is greater than equal to 5, so it is yes. and 5 and 4, is it monotone increasing? Yes, because 5 is more than 4, right? So what did we change here? We changed that 6 to 5. So this part you understood, right? Why we changed it? Because that is the point where you find out that that number is breaking actually the monotone increasing property, correct? So it's breaking here. So you change that 6, you reduced it by 1, so it became 5. Okay. So if you take a look at the answer here, we actually change that 6 to 5, right? Here other things are 4 5 is same what we have, right? So what we did here, after that we put all nines here, right? Why all nines? Because I want largest number there, which is smaller than the current number, but it should be largest. Okay, smaller than current but largest. So if I put all nines, then it will make it largest, basically monotone increasing. Do you agree or not with this, basically, right? You agree with this, right? It will become maximum, like the largest number. If I put 9, if I put 8 instead of 9, will it be largest? No, right? It will be smaller than 99999. Or if I put 6 there or 0 there, no, it will be smaller. So it will become largest only if I put 9 here, correct? Okay, so this part you understood. And why did I reduce it here? Because I am looking for a number which is lesser than this number, smaller or equal to this number. So it will only become smaller or equal if I reduce that 6 to 5, right? Then only it will become smaller. That is why I reduced that 6 to 5. Okay. So remaining numbers we don't have to change because they are already monotone increasing, right? These remaining numbers, which these numbers, these two numbers. Okay. So this is how we can solve this problem. So I explained you the logic also with some examples, and this thing will work for 332. So let's take a 332 example, right? So what I will do, I will go in this opposite direction. So 2 and 2 is monotone increasing. Yes, it is increasing, no problem. 2 and 3, is it monotone increasing? No, right? Because 3 is more than 2. So what point it broke? It broke at this point. So I will, what I will do here, I will, so it broke at this, sorry, at this point it broke, correct? So here I will make it 2, basically, correct? I'll reduce it by 1. So I put 2 here. These remainings are already 2, right? The remaining are already 2. I understood that this is the point where it is breaking the monotone property. I reduced it by 1. So what I will notice here, I will notice the index where I reduced it. The index where I reduced it is 0. So for the remaining index, what are the remaining index there? 1 and 2, because there are 3 digits there, right? So for remaining index 1 and 2, which are these two numbers, I will change these two numbers to 9, right? To 9. So the number will become 299, correct? 299 is my number. And why it is the so this number is monotone increasing? Yes, 99 is increasing, 29 is increasing, and this is the largest possible number which is less than or equal to the given number, correct? Which is monotone increasing. So we are greedily putting 9 here because we want that largest number, basically, right? That's why we are putting 9 there, correct? And we are putting 9 only after the digit which we reduced, right? The last one that which we reduced, right? So this will solve this problem. So I hope you understood the logic clearly, right? And I explain you in detail. I also explain you why this works, right? And why we are putting 9 there, right? And so that's pretty much it. So we'll just go through the code. You understood the logic clearly. You understood why it works also, and you also understood completely the monotone increasing digits property. So let's go to the Java code. We'll take a look here. So monotone increasing digits is the method that we are implementing. N is given to us, and this is going to return integer, which is the largest number that is smaller than the given number, right? So first we are going to take that n and convert it into integer array, basically. So because this is a number, so I will take this number which is given to me, whatever number, like this number or this number, and I will convert it into a integer array, basically 3 to 1. This is integer array I will convert, basically, correct? So that's what I have done it here. So I first converted it into a string, then by using chars method and map method, we are actually getting the digits array, okay, and 2char array method, okay. So this is the way you can convert a n, which is a number, into digits array. Now we have the digits array, we'll calculate its length, right, length of the array. So for example, length of the array here is 3, for this one is 3, right, like this. After that you will start going in backward direction, right. So let me remove all this. So what we are doing, we are going in backward direction. So you will read this 6 first, then 5, then 4, and you will keep checking that it's following the monotone increasing property or not. So if digits of I is less than digits of I minus 1, it means that you are breaking that monotone increasing property, right. You are breaking that property. Whenever you find that it's breaking the property, what you will do, you will catch that index into IDX, right. You will catch the index into IDX and you will reduce that digit by 1. This is what we have done here. So you understood that it's breaking the property here, so you reduce that 6 to 5 basically, right, and you kept going basically, correct. So that's what it does, right. And so here is the one for loop that you will need. After that, what we have to do, we have to go through this. So now this index I know, so this is what is the index here, 2, right. So what are the remaining index here? So 3, so this 3, 4, 5, 6, 7. So this index I will go and I'll keep changing it to 9. So I will get 1, 2, 3, 4, 5. 5 nines I will get after 5. So you will see here 5 nines I will get after 5. So this is what I am going to do here now in this for loop. So for I is equal to index I is less than digits dot length, I plus plus put 9 for all those digits, right. And after that, now I have to so now I have my answer in the form of array. I want to convert that form of array into actual number, right. So I am going to convert it into number. So for I is equal to 0, I is less than digits dot length, I plus plus. So 10 multiplied by num plus digits of I, and num is 0 in the beginning. So we are converting the answer in the form of array of digits to actual number, correct, and just return that number here, and this should solve the problem. So this is it basically. So let's talk about the algorithmic time and space complexity for this code. So we have a for loop here and for loop here also. So it means that we are actually on an order of n is the time complexity for this code, right. These are separate for loops. After that, the space complexity is because we have used this digits array here. So if there are n digits in that number, then your array will be n. So again, order of n will be your space complexity for this solution, right. So I hope you understood this clearly. So um, it's very simple. So first we have identified the index and reduced the digits by 1 for those index which are breaking the property, and after that we put 9 for those remaining digits that I shown you here, and then converting the digits array into actual number, right. So give it a run, make sure it compiles and works correctly against the test cases. The test cases are being passed, as you can see, and we are getting correct answers. So we'll submit this code now to the Leetcode, make sure the code gets accepted by the Leetcode, and as you can see on the left side, the code is successfully accepted by the Leetcode. So the numbers are changing, so I'm not very sure about these numbers, but this is the way you can approach and solve this Leetcode problem 738 monotone increasing digits, a medium complexity coding question. So it's quite interesting problem to solve. So I wanted to show you with this couple of examples the logic as well as the approach and the solution, how we can solve this problem. And if this whiteboarding session along with these examples helped you understand this problem in an easier and better way, then please give it a thumbs up to this video, give it a like to this video, subscribe to this channel. Your subscription is very valuable and important for the channel. It really helps and supports this channel. It takes a lots of efforts to come up with these examples, to explain these examples. So if you really want to appreciate these efforts, try to be generous, give it a like for this video if you really think that this video helped you understand this problem. and share this video with all your friends. Click on the subscribe button, subscribe to our channel, and click on the bell notification icon so you won't miss any interesting upcoming postings from our channel. Here we create content about computer science, programming, and different techniques of problem solving and how to solve different interview questions. The important playlist you should not miss from this channel includes graphs, matrices, binary search trees, binary trees, problems related to binary search, dynamic programming, recursion, memoization, how to use and apply BFS and DFS on graphs, matrices, and trees. The important data structures related playlist include stacks, queues, priority queues, min heap, max heap, and a lot more. So don't miss out on those important solved questions. They will give you a good prep for your interview rounds, will help you learn more about programming, implementation, as well as data structures and algorithms. Keep learning, keep coding, keep solving more varieties of coding problems, and most importantly, keep practicing. More practice you make for programming, different types of questions you solve, it will definitely help you in your interview rounds. And thanks for watching this video, and have a great day ahead.